Alright, CNT140, Chapter 14, we're going to pick up where we left off, talking about horizontal backbone wiring. Just super quick reminder, horizontal from the workstation to the horizontal closet, use your copper links. Backbone, connecting your closet, typically the main closet to the horizontal closet, between your switches. Oftentimes that's fiber optic, and this is kind of where we had left off. Horizontal copper cabling coming from the workstation into the closet patch panel, and then backbone, typically fiber, going between the closets, between our switches, if you will. That's very typical. Here's the drawing we've been using all semester, horizontal cabling. It's the the copper unshielded twisted paired link between patch panel and work area outlet, 90 meters max, solid core, all that stuff we've been mentioning all along. That's between the user horizontal, the user work area outlet. I'll get it yet. Horizontal cabling back to our patch panel in the closet. Meanwhile, the backbone is between my closets, typically between the horizontal cross connect and the main cross connect, between your switches, typically fiber, also called vertical cabling. And as we mentioned before, how I connect my switches together determines the type of backbone I'll have in my building. Just linking my switches together like so, daisy chain, I'll have a serial backbone. If I consolidate all my layer 2 switches into a layer 3, I'm going to have a collapsed backbone. If I do duplicate connections from the layer 2 switches up to layer 3, duplicate layer 3 switches, I'll have a parallel backbone. All depends on how I'm connecting them. Next question should be, how many horizontal cables should I run between the closet and the work area? Well, if I look at my 561C1 standard, it says a minimum of 2 permanent links. 568C1, as I go down through and start looking, horizontal cabling, a minimum of 2 permanent links shall be for each area. Yes, that's adequate. The standard calls for 2. You want to be thinking, is that enough? Is that enough for future? Do I need to overwire? That sort of thing. That's kind of questions that each business would have to handle, on their own. I'm going to pause for a second, get you thinking back CNT125 when we start talking IP phone. If I have 2 outlet jacks in an office, those outlet jacks could connect into a good quality phone, and then your workstation could plug into the phone. So 2 outlets on the wall could handle 2 phones, and then 2 workstations plugged into those phones. So I could handle roughly 4 things. That oftentimes is enough. But again, each company you need to look at, how long are we going to be here? Do we want to put some extra drops in for future, etc., etc. But the standard at least calls for 2. What termination method should be used? If I go to my 568C0, so I'm going to buzz up here to C0. Here's my C0 standard, and I'm going to go down to the termination area. This should be right below the cabling. Termination, okay? As I read these, that's where I'm pulling them from. Cable should be terminated with connecting hardware of the same performance. Yeah, all the categories should be matching the whole way through. Horizontal cabling, Cat 6. Patch panel, Cat 6. Work area outlet, Cat 6. Patch cable, Cat 6. All that should match. The category of the installed link should be suitably marked. Yes, we should be recording that. Cable geometry should be maintained as close as possible to connecting hardware. Yes, we're talking about untwist. The amount of untwist that should be minimal to termination point, and the standard even calls for different categories of cabling, how much untwist is allowed. And we're pretty much looking at 1/2 of an inch in anything we're dealing with at this current point in time. But I'm pulling them right from the standard. That's where I'm getting all that stuff from. What term method should be used? When we look at category 5E67, allows only one cross connect, contains no more than one transition point or consolidation point. Well, if you go back to when we start talking closets, we have main closet to horizontal to work area. That is typical. That horizontal is your one transition point, if you will. We can use an intermediate, and that still is adhering to the rule, and that also allows for the MUTOA that we talked about before. Multi-user telecommunication outlet assembly, that's a transition point or consolidation point. So they're trying to say, look, try to minimize it to main to horizontal to work area, and just have that one patch panel there, if you will, in the middle. If you need to do a consolidation point, that's okay. but you're trying to minimize the number of connections. Well, and the reason being, every time you have a connection, you have untwist and areas for interference or crosstalk. So they're trying to minimize the amount of connections that you have, the amount of terminations you have in your system, because all that adds up. All right, let's move into some stuff about horizontal backbone distances. And one of the first things the book mentioned is the primary goal of your telecommunications room placement is place it near the area they will serve. Absolutely. If I go to my 569 standard, let me buzz down here. It's around 53, I think, if I remember correctly. Yeah, here's your 569C standard. If I go in here, one of the first areas they mention, there's your closet layouts. In here we go. Locate distributor room as close as possible to the center area being served. I think if we look, here we go. Architectural and environmental. Locate the distributor room as close as possible to the center they are being served. Well, that's kind of what we did in our bid spec. We tried to find, all the rooms on our floor, and we tried to find a closet somewhere in the middle. And the idea really is you're minimizing your cable distance from the closet out to the rooms. And you're trying to get as many rooms connected as you can to that closet. That's not really too hard to figure out. And they also say there should be a minimum one distributed room per floor. Yes. I think down here, should be a minimum one distributed room per floor. All the pictures I've been showing you all semester show a closet per floor. Yeah, that's minimum. That way you can have the backbone cabling connecting between the two. Place tiers vertically one over another for multiple utility shafts. Yes, if I do have multiple floors, I should try to locate them above each other so I can drill through the floor, put a conduit. Again, I have to adhere to local fire codes and fire stopping and all that, absolutely. But I can connect my closet here on first floor to the closet right above me with a utility shaft, and all the cabling can go up, minimal cable distance, and everything's organized. I know exactly where everything is. That's the idea if I have a multi-floor building. Here we go. Closet here, right above it. I'm going to try to put a closet right above it, and so forth. If you can do that, that's what you're trying to do. How long for my horizontal cabling one? Well, this is something we've been saying all along. 568C1, 90 meters max. I'll buzz the whole way up here to C1. This is going to be, here is my C1, okay. In here as I buzz down through, I think it's right into the horizontal cabling, yep. Maximum horizontal cable length, 90 meters. Maximum horizontal cable length should be 90 meters independent of media type. Okay, we've been designing that all along. It also says C1, minimum 2 permanent links. We mentioned that just a little bit ago. And we also mentioned many times before, each 4-pair cable at the equipment outlet shall be terminated in an 8-position modular jack. And the other end of that is going to be the patch panel. Yes, absolutely. We've been saying that all along, and we've been drawing that and putting it into our drawings all along. 90 meters max distance from outlet to patch panel. Yep. What are the allowable backbone distances? Well, this is going to get a little trickier. 568C1. Backbone cabling extends from the termination of media to a main cross connect to an IC or HC. The cabling lengths are dependent on the application of media chosen. Okay, so if I go to my C1, I think I have in here backbone. Yes, this is where we have, it talks about the closets, and it even talks about distances. Cabling lengths are dependent upon media chosen, and it refers back to tables in C0. So if I buzz back to C0, here is my copper. Let me zoom in on this one real quick. Here's my cabling lengths. Copper, as you see right down the line, 10 base, 100 base, 1000 base, 10G base, category 3 up to 6A, all 100 meters, 100 meters, 100 meters, 100 meters, 100 meters. They say down here analog phone. If I'm using this for analog phone, I can go 800 meters. Yes, if I'm using twisted pair for my analog phone to a PBX, I can go 800 meters. If I'm doing IP phone across my data network, it's going to be the 100 meters that we're doing for all data. So that one's pretty easy. That's pretty much clear cut. So that's why I have this here. All my categories of cabling, I'm dealing with 100 meters data. We've been saying that all along. 90 meters max for the horizontal. 100 meters total when I include the patch cables on each end. Fiber optic gets a little trickier. Okay, fiber optic gets a little trickier. If I go to the next page here, this starts showing me different applications of bandwidth and my media, multi-mode, single mode, and different wavelengths. They're going to have different distances. So if I look at a 10G base S, here we go, 10G base S, with my 62.5, I'm looking at 33 meters, 5125, 82 meters. With my laser optimized multi-mode fiber, I can get 300 meters. So it really depends on the media I'm choosing for my backbone distances. So, and there's 2 pages of these. But this is your reference. If you're looking up how long I can go, that's a typo, that should be 568. If I'm looking up supported distances for my backbone cabling, I'm looking at that chart. I'm not going to have you memorize those, but I'm going to have you look a couple of them up as time goes on. Okay, now into estimating our drop length. Well, I need to think about how am I going to route my cabling. There's 2 major ways discussed. I can do diagonal or I can do orthogonal. Diagonal is direct wiring. I literally go from the closet in a direct line to my rooms. So if I take a look, oops, I jumped back here accidentally. Here we go. Here's diagonal wiring. If I could leave my closet and go in a straight line out to my rooms and drop it in, that would be the straight line distance. That doesn't usually work so well in school rooms and buildings, but it could work in places like warehouses or wide open facilities. You know, I'll pick on a very large, commercial store where you have lots of wide open rafter spaces. I could potentially go straight line over down the wall into a drop. That would be your diagonal wiring. Okay. The other style, orthogonal wiring, where I use right angles, use cable trays. Here we go. Here's right angles and cable trays. Cabling leaves the closet, goes in a cable tray down the hall, and then cuts out of the tray and into the room. This is all right angles. This is your orthogonal. Orthogonal with cable trays, like I do probably in most businesses, or like we're going to do in our building, our school building, if you will. This one, let me back up here, uses roughly 40% more cable. Hence why we did the 1.4 multiplier in the bid spec. We're adding the 40% cabling necessary to go around corners and obstacles to do this right angle. So as we measured here, we measured straight line, we added 40% to make up for these right angles that were going to be involved with your orthogonal wiring. That's your cable tray method. That's again why we added that 40% in our bid spec. So I need to know how am I going to route it, and then I can, like we did, use a method to estimate our cable distances. All right, I'm going to stop here. The next podcast I'm going to come back, we're going to dig into the 569, talking about our closets.